something really satisfying about watching an old pong ball bounce, huh? Especially when you wrote it yourself. Okay, so enough fun and games, I guess. One of the viewers mentioned using a debugger, and so I was like, well, I rarely use them, but maybe I should look into that too. So I looked at some videos, and oh my god, what a nightmare. Just, I mean, not too hard to use, but getting started, getting them set up was such a pain. I was like, wow, if I got to jump through that many hoops, why don't I just write my own debugger for all it's worth? Or a very crude facsimile there. But here's the thing. We've been avoiding printing any values to the screen other less than 9, 1 through 9, because as we know, everything wigs out and it goes off into the non-printing characters and everything else. Yes, but this is something we're going to need to face eventually, how to print values to the screen. Well, if you're only out to make games, maybe not, but this is an important exercise, I think. I wanted to do this. Like I said, I was watching some of the debugging videos, and the feature where you could look at what's in the registers. I was like, well, that's handy. I could write that myself. So why don't we write that ourselves? And I'm just going to wipe out everything entirely because I have a plan today. I remember when I was reading, various programming books, and at the end of the chapter there'd be like a little exercise or something that the author would give you, and I would do them, a little challenge, So it was kind of cool. So today, we'll explain what I'm going to do first. I would like to make it so I can take one of those register values and print it out in hex. We'll do decimals next, I guess, or later, in a later video, but I figure we'll tackle hex first, so that we can actually look at what's going on when we want to. Okay, so the first part of the assignment, if you've been following along with this series, you should be able to do this first bit completely verbatim off the top of your head from memory. So why don't we try that? When I say we, why don't you try that? So all we're going to do, we'll start in, we'll use the default text mode, right? Right. But as you know, I'm not going to clear the screen even, right? So we don't need to call default text mode. We're just going to use the default text mode. I'm not going to tell you what that is. You should know. First thing we're going to do in our program, we want to load a value. We're going to start small, right? Like, how do you print a big value out as a hex? Well, we know it's going to be what? A value from 0 to F, right? So somehow we're going to need to check if that value is a number or if it is a letter, right? If it's, in other words, if it's 10 or more, we know it's alphabetical, right? Or alphabetical. Okay. So yeah, and of course by now, now in the early video, we did the filling the screen with zeros, right? And then ever since then we've just been copying and pasting. So that was like, what, 30 videos back, but I've done it a number of ways. Perhaps you can recall off the top of your head, and just print it off. And of course, the very first lesson, really, that magic number, baby. Yeah. Check if we got a value. You should be able to do this totally. just on your own. Once we have that value, of course, we're going to adjust the offset, right? So we can print out that ASCII, all right? And you, of course, then should know how to call that teletype, yeah. There you go. There's your assignment. Why don't you just pause the video, see if you can figure that out, and then I'll come back and show you my solution. And likely the way I do it will probably end up being slightly different from yours, but as long as yours works, then we can proceed from there and plug that right into the next video. So go ahead, hit that pause button and give my little challenge a try, and then we'll continue. Did you do it? Well, because if you weren't able to do this off the top of your head and you've been following this video series, I have failed you as a teacher. But I will be honest with you, the very first time I challenged myself to, I didn't have my references nearby, and I'll just do it off the top of my head. I still had to go look up this part. You copy and paste things 20 times a day, and are you really looking at it and absorbing it? Well, not until you can do it from memory. So it's good to challenge yourself. Remember, this isn't grade school. You're not cheating me. You're only cheating yourself, right? Okay, so what do we know? DW 43605, 43605, which, as you all know, is the zip code for Toledo, Ohio. Yeah. Here we know what was it, DB0, right? And we want to fill 512 bytes minus these two, so that is 510, right? And times 510 times. We want to do that, and then so that fills it up if there's nothing in here. Otherwise, we want to subtract everything up until this point, minus, you remember, for every dollar you make, you go $2 in the hole, right? Yeah, pretty straightforward. Load of value. It's only 0 to 15, and might as well just go straight for the lower register, where I don't need to use AX. I only need a byte. Let's just put a arbitrary value in there between 0 and 15 for starters. Print the character to the teletype. We all know that is move into the upper register. What was it, 14? Pretty straightforward. And then, of course, do it, right? Yeah. Okay, so we basically have two more things to go here. Adjust offset for ASCII printout. Okay, we know that too, right? Add to the lower. Yeah, what am I doing? This. Yeah, that'll give us some printout, right? That should actually do something already. Huh? Won't that print something to the screen? Yeah, print something. Okay, so we have, it's 15. Why do we get a question mark instead of a value? Because it is more than 9, right? So it goes off into some other wonky characters. So that's the purpose of this exercise, actually. Okay, so what do we got here? If the value is more... Okay, so this is a trick question in a way. I kind of worded this backwards. You want to think of it kind of the other way. If it is a number, if it's less than 10, we want to here do nothing. Right. So otherwise we want to here, let's look that up, shall we? Here, I'm gonna go open, and I don't know if I instructed you to save a file called print all characters, but boy is it handy. I'm just gonna save right over my file because I know I can come back to it. Excuse me. Sorry, got a little confused. Print all characters. Copy all. Make sure it's read only so you don't start messing with that. Go over here. I'm just going to paste over my working file. Save that, and we will look at our references here. Okay, so here, and here, let me go back. If value is 10 or more, adjust the offset for the alphabet. Okay, so here we go. We got a value. We're adjusting, so it'll start here in the numbers. However, if it's 10, we want to print this A, right? So that's 10 plus 1, 2, 3, 4, 5, 6, 7. That should print an A, all right? So essentially, if it's less than 10, skip to here. Right? Do nothing. Nothing. Plenty of nothing. Right. So that means we want to do a compare here and jump. Here I said if value is more than, right? So, but if it's less than, jump to do nothing. Jump to here. JL to here. Yep. Otherwise, go ahead and add that offset. Add AL 7 more. Yep. So let's get that comparison happening. That is compare AL. Compare L to 10. Yeah. If it's less than that, skip to here and go ahead and print it out. Otherwise, just proceed normally down and compensate. Yeah. Add in that offset for alphabet. Yeah. Offset. I always get my colons and semicolons backwards. Offset for chars to print a character. Well, teletype, we know. Okay. I'm just waffling, aren't I? There you go. We got an F. However, if this was 10, we got an A. Ha ha ha. And is it less than 10? Let's try 8. There's our 8. There. Okay, so that's the first step. We're able to print out a single value from 0 to 15 as its hex equivalent. Now we can proceed to being able to do that with the rest of the numbers. Okay, that was a pretty good challenge. Next, I'd like to turn all this into a subroutine so it is a little bit more flexible. What does it do? We print hex digit, I guess. There, so I can call that. That means down at the bottom of everything we want to return. There. So now I can just call hex, print hex digit. It'll print whatever is currently stored in AX or AL, as the case may be. Nice. Okay. Furthermore, we'll just call this print character. There. Yeah. So now all of this is quite flexible. If I only wanted to print a character, I could call this and it would return. If I wanted to print it with a numerical offset, I could call this and it would do that, add that, and then flow through and return. Nice. If I wanted to print it out in hex, I would do it up there and it would flow through and return. Nifty. All right, whoops, load the value out here. Yeah, that's very good. Okay, that was a level 1 challenge. Let's up the bar a little bit now. This time here, we started with a value from 0 to 15. Let's go 0x AB, like that, shall we? Yeah, no, not OAB, there. Okay, so what we did, and just for a bit of a clue, of course, before we did, if this will help, I'm jumping from a level 1 challenge to a level 3 challenge, I guess, here. Before we put in, what did we put in? 15, yes, which is hex for what? Yeah, right. Yeah, so that's a bit of a clue, I guess. So based on what we have done in the past, although, yeah, that was a very brief reference. If you are able to accomplish this challenge just based on what I have showed you, it's all in there, then you are far brighter than I should be taking lessons from you. Okay, but you can give that a try if you want to pause the video. Yeah. We want to do that. Only print this nibble, it's called. Right? You got your 1, 2, 3, 4, 5, 6, 7, 8 bits in a byte, right? So this value is this much. That's what we want to print out. That's also a blatant clue, isn't it? There you go. So I'm going to go watch some TV and go to bed, and what will be a matter of seconds for you in the video will be tomorrow for me. All right, another day, another dollar minus dollar, I guess. So where did we leave off? Well, this is interesting. I had a power outage just earlier, working on my file, and got fairly far along, and then boom, and complete blackout. You know, oh great, lost all my work. But then once the power resumed, I turned on the computer, and Notepad++ took me right back to the state here with the red indicating that I hadn't saved yet, and it was right where I left off. Brilliant. Kudos to the programmers at Notepad++. My regular Notepad, where I had some notes that I was working on, that was lost. So, okay, that's some top-notch programming there, that's for sure. I know it keeps like a backup, of everything you do as you go, and that's how you're able to do undo, all that stuff, so. Handy. Okay, so the task at hand was printing that out. If you were able to do that, you're my star pupil, I guess. You are exceptionally bright. For those of you that are relatively bright, I can give you a further clue. I guess that would be in the print binary video, which if you have been following the entire course, you would have that in lessons. I assume you would have the print binary there. Yeah, I'm not sure what state it was left in for you though. Here, let me pause for a second. Top half of file, bottom half of file. Yeah, you can double check that. I may have added this. No, that return is part of the print loop. Everything is all good. Okay, so but I may have added this myself, independent. I don't recall if I told you in the video to turn this all into a subroutine of sorts. Okay, but if you haven't seen the print binary video, then like I said, that's a blatant clue, isn't it? On how to solve this, how to print that bit there. Okay, so you would want to pause the video, go there, do some research, come back and resume, so that you have this file and you're all ready to go to copy this out of here. And then we're going to head back over here, and then after all of these other subroutines, I'm going to add yet some more. Here, printed is not going to cause any conflicts because I used a unique name. I think we're good on that. So that means that if all went well, I should be able to go up here and halt there, and I just want to call my print binary and have a quick glance. Call it, I said. Call print binary, and it should show me what's in there. Let me just make this 0F to avoid complications for the moment. Let's see what we got in there. Yeah, but there's some other stuff there. Why is that? Because here, this needs to be AX. So you want to fill up that entire AX register to be read. Because, yeah, we're looking at top. Yeah, okay, whatever. Save that. What do we got? Yeah, okay. So that's all working. Good. Okay, so that lets me have a peek at what's going on in there. Right? Okay. So let me see if I can we'll make this AF. Whoops. AF. Yeah. Let me just hang on, let me just glance at my phone. What's that? Oh yeah. Okay. What happens now? I'm gonna go save that. Get out of here. Let's see. Yeah. There's the full AF value. We made a nice utility for reading binaries and stuff, right? Okay. So the question is, how do we get to just this bit right in there, right? Okay, so one possible way would be, let me just make a crib note here, I guess. So I got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. But it's got a number in there. Let's do that. It's got a number 1, 0, 1, 1, followed by 1, 1, 0, 0. Okay. So we want to get to this 1, 1, 0, 0. If you've already figured all this out, you're like sitting there going, yeah, right. Okay, but one potential way to get to this, I guess, would be to shift left, right, until all of this, until this ends up over here, right, and then, so there, we shifted it left, right, and then take a snapshot of just this somehow, and then shift it right again, so resulting in that, right? I hope this makes sense, so now you would end up, if you started with that, you would know the end result would be only that bit. Okay, that's one way to do it. Okay. Another way, after that long explanation, here's the easy way. Let me see, is print a. Okay, we got our value in AX. Okay. Okay. Good to start. Here's what I want to do. And new command here. And let's see if this works. Even AL. Okay, it will be. It's actually OXOF. Okay, but I'm gonna put something in here. All right, here, let me put this A in there. Okay, there we go. Okay, so what am I missing here, folks? AL, comma. There we go. Okay. Having such a hard time explaining things, even though you know them in your head. Okay, so let's just see what happens now. So this is what we got for printout when we called print binary up here. Okay, let's now call it under here after we do the AND operation and see what changes here. There. We have effectively masked out the first 4 bits. Okay. The AND operation, anyway, so now I have this separated. Okay, very nice. Problem is, okay, so good, there. I have now printed out just that as a binary value, right? Okay, so that means if I now instead call this, or just remove the CLI and flow through. Let's see what we get. Save that. There's my isolated F. Okay. So I have printed just the lower nibble. Yeah. So here we go. What is this? Mask out the high nibble. Yeah, that's what I have done. I know it looks like I just moved this value in there, so maybe I should have used. Here, let's do this. Here, I want BB. Okay, there. So, just to clarify. There's my B. See, the F had nothing to do with it. I'm using this value effectively made the. I'm not being too redundant. I just want to make sure I'm not missing the point. 1010, and then I got 010 1. Okay, so calling this turned all of this into there. To make a short story long, I guess. There, okay. So now we have gotten to that part, right? Next, we're going to do the get to the high nibble. Okay. So clearly, as a result of doing some stuff to whatever was in here, we have lost that original value that we started with. It would have been AB, right? So now it's gone. You know, we can print out that B, fine. That is our print low nibble, actually. Yeah, we're printing the low nibble there. Where is it when I and? Here. Right, I'm sorry. If I put this right under there, the two of those together are print, always, print lower nibble, right, 4 bits, yeah, got it. Okay, so now we want to print the higher nibble. Okay, actually we're going to do that first, and then we'll get to that lower nibble afterwards. Here's the thing, though. We're messing around with that value, so after doing an operation, whatever is left in here is gone. So what we want to do is we have our initial value loaded. We want to put that aside for safekeeping, I think. So why don't we just push AX there. So now it's in storage, you know, so we can do some operation and then later come back down here and pop it again. So it is restored to do this operation the second time. Okay, so but as far as what's going on up here, this is loaded. I've made a backup. I may now do the print the high nibble. Okay. Okay. Essentially, to do that, first I want to move what I have in AL. Let's see. Yeah, into AH. Yeah, I'm sorry. Move AH, AL. Okay, and then we'll go shift right, AH4. Let me see. Whoops. Shift right, AH4. Move AL, comma AH. Move AL, comma AH. And then let's call print hex digit here. Let me just I'm going to turn all this off for a second. Yeah. See what I got. Error. Alone 8. Call print hex digit. Yeah, very nice. So that printed the high nibble there, and then we're gonna pop the original value back in there and print out the other nibble. C AB. Brilliant. Wow. That was actually kind of fun. Okay, so there we go. Next, we want to up the bar to let's make it A, B, 07. Yeah. Okay. So, but before we do that, you should definitely save that. Call it, print low nibble hex, something like that. Yeah. Print hex lower nibble. Yeah. Print hex lower. Yeah, good enough. Print hex lower. I would advise you to save that for lower for later. Let me see something. Save as. Yeah. Print hex lower, something like that. All right. Next, we will do the even more complicated challenge, how to get all of that. We've made a bit of code that prints the high nibble and the low nibble. Together, that is a byte. Let me encapsulate that. We'll go call this print hex digit, I guess. Print high nibble, print low nibble. Sorry, print hex byte. My bad. Print hex byte, like that. Yeah. And put the label in there. Okay. Now, so when I call print hex byte, it'll print the higher and the lower nibble. So now we want to separate the upper byte and the lower byte. So we've made a backup. That means we can get to this part and then that part. Nice. To do that, okay, it's all pushed. It's already in memory. Made a backup. Now I want to get the higher register first and just simply put it into the lower register so I can print it. No problem. Move AL AH. There. That's all I gotta do there. And then call this. There. Call you. There. And that should do that. Takes care of the higher byte. To do the lower byte, all we need to do now is call that backup value, pop AX, yeah, and call this again. I guess. Can't be that simple. Let's see what happens. There we go. Oh, AB 2333. Why is there still a little bit? Oh, got it. Because we are done here. We are done here, folks. End of program. And that is all she wrote. Let's see. Definitely. Right. Good. So we can put whatever in there. There. Yeah. Prints out full 16-bit hex value. So save that as print hex 16-bit. By all means, that will come in very handy for future reference. Is everything marked up properly? Good enough. Yeah, I am quite happy with that. All right. Printing a hex value.